Hi there, this is Math 7, Unit 6, Lesson 8, Reasoning about Solving Equations, Part 2. And we're still going to be using hangers today to understand two different ways of solving equations with parentheses. So first of all, I'll begin with a section called equivalent to 2 times the quantity x plus 3. Remember, we're looking at things that are equivalent to, it almost has a little bit of that word equal in it, meaning it's pretty much the same thing. And this little section in its warm-up is really dealing with, do you remember the distributive property? Is really the question here that's in play. And so when you look at these different expressions here, we're trying to decide which ones are equivalent to 2 times the quantity x plus 3. If I was to go back and recall the distributive property, what that allows me to do is to take the number on the outside of the parentheses and I'm going to multiply it by each term on the inside. So I'll do 2 times an x, which becomes 2 times x. And then I still have the plus, so that just comes down. I have a plus sign there, no problem. And then I'm going to distribute the 2 times the 3. So I can write that as 2 times 3. Now the next step from there is actually going to be to usually combine that. So 2 times x simply becomes 2x. I still have a plus sign, and 2 times 3 becomes a 6. And so I can rewrite that equation a couple different ways, using the distributive property first, right? And then combining things up to show what that looks like once I've done the distributing part. So looking over here, I have 2 times the quantity x plus 3. This is just showing that there's a multiplication piece between 2 and that part, which is true with this as well. I just don't have to label that. Whatever number is next to that parenthesis means I'm going to multiply it together. So I don't have to write that multiplication symbol. I can just leave it alone like it is there. But this one, though, is equivalent, no problem. Here, we have the quantity x plus 3, and it's being multiplied by 2. Nothing wrong with that at all. That's going to actually get you the same solution. If you were to take a look at the x plus 3 and put the 2 over here, again, distribute property, I do 2 times 3, which is 6, and this is plus 2 times x, which is 2x. And so we're in the same exact spot as we were before. The 2 is just on the other side. All right, so that's going to work. Over here, we have 2 times x plus 2 times 3, which matches right there, our first step in the distributive property and process there. So that's going to work. Here we have 2 times x, that works, plus 3. Well, the 3 is missing something, isn't it? It should multiply with a 2, so that's not quite good enough. Here I have 2 times x, and again, the 3 doesn't have a friend, so it's not going to work. And over here, we end up with 2 plus x, and that's the quantity 2 plus x times 3. So this is putting the 3 on the outside of the parentheses and the 2 plus x on the inside. That might look like it works, but reality is it doesn't. Let me show you real quick. If we had 2 plus x and we multiply by 3, it doesn't matter if it's on the left or right side. I'm going to put it right here for now because it's still the same. And I do 3 times 2, and you go, well, that's 6. That's looking good, right? Except that then you do the next one, and it's plus 3 times x, which is 3x. So that does not match our 2x. It's not going to work there. So that'd be a no. So only ones that work are 1, 2, and 3, and that's really just a review of the distributive property. So this next part here is called either or, and it says to explain why either excuse me, of these equations could represent this hanger. So we have 14 equals 2 times the quantity x plus 3, or 14 equals 2x plus 6. So why could either one represent the hanger there? And based on what we just did a second ago, we can see that if I distribute this 2 into the quantity x plus 3, I'd have 2 times x, which is 2x, and I'd have 2 times 3, which is 6. So these equations are the same, it's just one has the 2 on the outside, or factored out, we might say, and over here we have it distributed through there. Looking at the hanger, it's a similar situation as well. They both have the 14 over here, which is what's going to be equal to. So 14 is going to be equal to this portion of the hanger right there. So with this part of the hanger, I could look at it being, well, I have a group, right, of x plus 3. That's a group there. And I have another group of x plus 3. And so in reality, I have 2 groups of x plus 3. That's one way of looking at what's on the right side of that hanger. I could write it like that. I could also, though, just look at it and say, well, I actually have an x and an x, so that's 2 x's, and I'm going to add that together with a 3 plus a 3, which is 6. So I could do the 2 times quantity x plus 3, or I could do 14 equals 2x plus 6, and it really is the same equation, just something written a little differently depending on how you see things there. All right? The next thing says, well, find the weight of one circle and be prepared to explain your reasoning. So it really depends on which way you want to do this. There are a couple approaches to this one. Let's look at both approaches. I'm going to do 2 approaches. First of all, we could take a look at the picture and say, well, if I look at it as being 2 groups, this one here, 14 equals 2 times x plus 3. If I look at it as 2 groups of x plus 3, if I take that 2 and I divide this side into 2, right, break that into 2 pieces, this becomes a value of 7 and 7, and that really means that that part goes with that. So what I have is I have the value of 7 is equal to one of the x plus 3's. How do you get there? How did that happen? Well, if you think about mathematically, what we're doing is we're taking a 2 from this side, and we're dividing both sides by 2 in order to come up with a 7 there, and leaving the x plus 3. To solve for this, I have to ask myself, what number plus 3 gets you to 7? We would say, well, that's going to be a 4. How can I solve that for real? I could subtract 3 from both sides of the hanger, and you end up with x equals 4. So that works out just fine. If I look at the other equation, I could have 14 equals 2x plus 6, right? So when I go up here to this side, if I erase this real quick, 14 equals 2x plus 6. So I'm not having the groups here, not having the groups there. So what are we going to do here? Well, in this case, I have 2 x's and 6. If I have 14 there, I would subtract this, the 3 and a 3, which means subtracting 6 from there. So that becomes equal to 8 is what's left on this block. All right, the 14 goes away, and I'm left with just 8 in that section. By removing the 6 over here, I remove 6 over there. So in an equation, that looks like subtracting 6 from both sides, and we have just the 8 left over there. So now knowing that I have 8 over here, and I have 2 circles, so I'm going to cut this in half, and by cutting that in half, I end up with 4 and 4, and so 4 is going to be equal to 1 circle, or in this case here, x, which is the same as dividing both sides by 2, and 8 divided by 2 is 4. And that's the idea there. So that's what we're working on. Let's look at the next page and look at some more hangers and solving equations again. So here are some balance hangers again. Each piece is labeled with its weight. We can see over here this hanger, we have x and a 5, x and a 5, 2 groups of that, and 16 here. So what we're seeing is that we know we have an x plus 5, x plus 5, and we have 2 groups of that, and it's going to be equal to 16. That's what we're looking at in terms of these problems here. All right, and so we have 4 hangers, and our question says, assign one of these equations to each hanger. So we just did the 2 times the quantity x plus 5 equals 16, so that's the first one. Maybe I call this one A, B, C, and D for now, so this will be our A. Over here we have 20.8 equals 4 times the quantity z times 1 plus 1. Well, the 20.8 is right here, so this is going to match C. So I could write that as 20.8 equals 4 times z plus 1.1. Alright, here's 3 times quantity y plus 200 equals 3,000. I can see a 3,000 there, and this has a y plus 200, and I have 3 of those. Right, so that's 3 of the y plus 200s equals 3,000. That's going to be our B1. And then finally our D is here with our 20 thirds equals, we have W plus 2 thirds, and we have 2 of those. So those are our 4 different equations. So the second question says, explain how to figure out the weight of a piece labeled with a letter. So how do you figure out the X, the Y, the Z, and the W by reasoning about the diagram, okay? So when you look at the diagram, how do you figure that out? How do you figure out what that's going to be? So when we look at this diagram here, if I'm trying to solve for X for this one here, not worrying about doing an equation, but just the diagram, to find out what x is, what I first do is I recognize that, like before, there are two groups of x plus 5. Meaning, I want to figure out first of all what one group would be. So if I have 2, I'm going to cut this into an equal halves, right? So that I have basically like this, chopping that up. So instead of having a bar of 16, I have 2 bars, and they each have a value of 8. So half of this bar, 8, is equal to x plus 5. Now in order to get the x by itself, I want to take away 5 from here, and at the same time I want to take away 5 from here. And 8 minus 5 is equal to 3. So what I have left on this side, once I remove 5 and 5, is I have 3, and that will be the value of the circle or the x over there. And that's what's taking place. If I was to do the same thing with the equation, reasoning about the equation, right, I have 2 times x plus 5, like this, equals 16. So to do it with the equation, we have to divide both sides by 2. That gives us the x plus 5 equals 8. I subtract 3 from both sides, and x is, subtract 5 from both sides, and x is equal to 3. So you can do it by reasoning of just the picture, or you can do it with the actual equation itself. And that's the idea of what you're going to be doing there. We do it again and again. And that's really what this lesson was about. So this is our summary, and it just says that a balanced hanger shows, right, 3 equal unknown weights and 3 2-unit weights. So we have our unknown x, x, and x, and our 2-unit weights here on the left side, and an 18-unit weight on the right. So we have these here, and so the 3 unknown weights plus 6 units on the left, we can represent with a balanced hanger and equation over here. So what we have is we could say that this is 3 x's, 1, 2, 3 x's, plus 6, which is 2, 4, and 6, and it's all equal to 18 right there. And you can write that equation just like this, and we can solve it as we did before, subtracting 6 and solve for x. We could also recognize that this is 3 groups of x plus 2, x plus 2, x plus 2, x plus 2, and we have the same equation, right? And because of the same equation, we end up dividing both sides by 3 and having x plus 2 being equal to 6. And when we look down this next part here, the idea is that if I had this group here, I can cut this into thirds. And here it is cut into thirds. So I take the 18 and I have to split the 18 up 3 equal ways. That becomes a 6 and a 6 and a 6. So what I have left here is I know that with my hanger, I have an x and I have a 2 that are equal to what's left is the 6. And that's what we're showing here, and this is happening in this case 3 times, but my goal is to get the x by itself, so I can look at it as just 1. The same process continues, and we look at here as well, how do I get rid of the 2? I can subtract the 2, and we're good to go there. That works out just fine. So that's the idea. You kind of work your way through. Here's what we were left at with the x plus 2. We would divide by 2 or subtract 2 there, and x would end up equal to 3. So there's lots of steps to help you get there. The summary reviews a little bit. Let's pause and just take a moment to look at your homework together. All right, here's your homework. All right, write an equation to represent the hanger. So for this hanger, I notice I have 2 plus x, right? I have 2 plus x, and I have 1, 2, 3, 4, 5 of those. So I have 5 times the quantity 2 plus x is equal to, what's on this side? 11. So that's my equation that represents that hanger. And if I want to solve the equation by reasoning about the equation or the hanger, that's what I'm going to do. I'm going to do it with the equation. Same idea. I could first of all divide both sides by 5, right? Looking at this, I kind of recognize that, well, if I divide both sides by 5, I'm going to end up with 11 over 5, which is a little bit of a weird number, right? That would be okay. So I could definitely do that. I'm going to do it that way just for fun real quick, okay? So if I divide both sides by 5, I end up with 2 plus x equals 11 over 5. 5 goes in there 2 times, So I end up with 2 1/5 if I write it as a mixed number. Right? So that's a little bit funny looking already, but that's okay, it does work. I can get the x by itself by subtracting 2, and x is going to be equal to 1/5. Nothing wrong with that, it works just fine. I could also do what I did in my first activity today. I could do 5 times quantity 2 plus x equals 11. I could distribute first and do 5 times 2 is 10, plus 5 times x is 5x equals 11. I can subtract 10, so that 5x equals 1, and then divide both sides by 5, so that x equals 1/5. You can see doing it this way or distributing still results in the same answer of x being equal to 1/5. If you use it as a decimal, that would be 0.20. That's what it looks like as a decimal if you try to do that. And that's the idea. Could I do it with a hanger? Sure I could. With a hanger, we're looking at these 5 groups, and we'd separate this into 5 sections, right? 1, 2, 3, 4 sections like that. And when we divide 11 by 5, you end up with, like we said, 2 1/5. So this becomes a 2.2. That's what 2 1/5 is. 2 1/5 is equal to 2.2. Sorry. So we have 2.2, 2.2, 2.2, 2.2, 2.2, 2.2 for all those sections there. And so one section of this would be equal to 2.2. And we would subtract the 2 from there so that x is equal to what's left, just the 0.2. Because 2.2 minus 2 is equal to 0.2. And that's it. Let's look at number 2. Number 2, explain on each part of the equation. 9 equals 3 times the quantity x plus 2 is represented in the hanger. Alright, so x is over here, and x is our unknown value. That's our unknown weight. Our unknown weight, that's our circle, right? That's where the x is going to be. We don't know what that is. We just know there happen to be 3 of them. That's all we got so far. The term 9 is probably going to be standing for what's on the left side, and that's going to be the 9 squares, right? That weigh I don't know if it's 1 unit, whatever you want to call it, 1 unit each. That's our 9. That's over here on this side. 3, what is 3 going to be? The 3 to me would be what's on the right side, and that's going to be the groups that we have. We look over here, we have 1 group, 2 groups, 3 groups right there. So this could be equal to 3 groups of something. What are those groups going to be? In our case here, right? What's this? Our group value on the right side, which is going to be an x plus a 1 plus a 1. Well, x plus 1 plus 1 is really x plus 2. So I could put that in there right like that. And this one here is going to be the sum total of the right side. Right, that's the whole thing, 3 times that. The equal sign is going to be the hanger. That's where the equal sign is. This is our equal sign. Okay, because this equals that, so it's shown by the equal sign. That's why it's balanced like that. Alright, looking at number 3. Select the word from the following list that best describes the situation. A little review thing about some money. So here we go. This first one, we have a deposit into a savings account, and every year the amount of money in the account increases. So it's a deposit and it's an increase, and then when you have a deposit into a savings account with an increase, we call that an interest. So that's going to be F right there. For a car sold, salesperson is paid 6%. So when a salesman is paid a percentage, we call that B, a commission. Someone who eats at a restaurant pays an extra 20% of the food price. The extra money is kept by the person who served the food. We refer to that as a tip or a gratuity. That's going to be E. An antique furniture store pays $200 for a chair, adds 5%, and now it sells for 50%, and now it sells for $300. We call that a markup. Normal price is $600, but it's on sale. On sale means it is a discount. C. And for any item you purchase in Texas, you pay an additional 6.25%. That's going to be considered a tax. And finally, number 4 today. It says Claire drew this tape diagram to match the equation 2x plus 16 equals 50, but she got the wrong solution as a result of using this diagram. Alright, so here's our diagram. Our equation is 2x plus 16 equals 50. Alright, so we can see she got it wrong because of her diagram, not because of the equation, but something was wrong in this diagram here. We're going to get to that here in one of these other questions, but let's look at the first thing. It says what value of x can be found using the diagram? So if I use this diagram as it is, what do I have? I have a 2 plus an x plus a 16 equals altogether the 50. That's what she actually has as an equation, which you can see doesn't match that right there. The 16 is good, the 50 is good, but the mess up is coming right in here. Instead of having 2x, she has a 2 plus an x, because these are separate boxes and they represent different things. If she was to solve this, you'd have x plus 18, because I combine those together, equals 50. We would subtract 18 from both sides, and so x would be equal to, in our case here, 32. That's the wrong answer, but that is the answer she got using that diagram there. So show how to fix Claire's diagram to correctly match the equation. To fix the diagram, what she should do is she should take her tape diagram, and we should divide it like so. Keep the 16 where it is, but she should have two boxes that show an unknown value x, and the whole quantity of that would still be 50. So this one right here should turn into an x, so you have 2x plus 16 equals 50, like we wrote there. In order to find the new value, or to find the value of x, what we would do is we could rewrite that then as 2x plus 16 equals 50. We subtract the 16 from the 50, so that 2x equals, in this case, really 34. Divide both sides by 2, and when we do that, we discover that x equals 17. All right. And the last question just says explain the mistake. That's our D thing. What was the mistake? The mistake she made is right here in putting a 2 there to represent that 2. It should be 2 boxes of an x. So 2 groups of x's is what it should be. That was her mistake. All right, that's it for today. We'll see you next time.